Hi everyone, thanks for tuning into our video today. We're going to talk today about solving a quadratic by factoring, or simply just factoring a quadratic in general. Before we do that, let's do a little practice on adding rationals or solving a rational equation. So at this point, I would encourage you to pause this video, give these two problems here a try, and when you are done, come back and unpause the video to check your answers. Okay, here are your answers to the opener problem. If you need to pause the video here to check out this for a longer period of time, please do so. Otherwise, we're going to move on to what we're going to talk about in this video. So our first 6 problems here, we're going to talk about just factoring completely. So when we talk about factoring, the first thing we always want to look for when factoring is called a greatest common factor, or more commonly abbreviated as a GCF. And after that, we have a lot of different options on how to factor something. We'll go through as many of those as we can as we see fit in these 6 problems. Number 1, our first thought is there a GCF? There is not. So we can try to factor this trinomial into 2 binomials. X times x would give us x squared. And numbers that will multiply to 48 and add the -2, that would be -8 and +6. If we were to redistribute this out, we would get back to our original problem. Second one, is there a GCF here? There sure is. So we factor that out. The GCF is 2. And then at that point, again, we will look to see if can we factor this trinomial into 2 binomials. Well, let's see. Well, I know y times y would give me y squared. Now we need numbers that will multiply to 18 and add to -9, and that would be -6 and -3. Number 3, this is called a difference of squares. Why is it called a difference of squares? This difference, this is a perfect square, and this is a perfect square. So this is going to factor into 2 binomials. 4x plus 1, 4x minus 1. Because the square root of 16x squared is 4x, the square root of 1 is 1. So a difference of squares will always factor in the form of a plus b, a minus b. Number 4. So this is our first real tricky one here. We have no GCF. So it's just factoring a trinomial into 2 binomials, if we can. So if you looked at my last video, we have 4 different ways of going about this. As I mentioned in that last video, I prefer just guess and check. So I know that the only way to get 5 is 5 and 1. I know one of them is going to be negative, one's going to be positive, but I'm not sure which one yet. The only way to get 6 is, there's 2 ways, is 6 and 1 or 2 and 3. So I got 4 combinations. I could do 6 and 1, 1 and 6, 2 and 3, or 3 and 2, right? So let's just take our best guess and see. Remember, the insides have to add to 7. So if I was to guess, let's go 3m and 2m. That would be that bottom one there. And if I wanted plus minus, let's see what we would get. -3, +10. Well, that's just a lucky guess that we got on our first try. If we didn't get that, we could change the signs, or we could change the numbers that we see there. But we got it right, and there's our factored trinomial. If you don't like the guess and check method, remember the other methods we talked about yesterday: bottoms up, the quadratic formula, or grouping. Here's another one. There is no GCF here. Okay? So, let's see if we can factor this. Now, 4p squared, you're either going to do 4p times 1p or 2p times 2p. Let's start with 2p times 2p. For 9, so it's got to be adding to 9, or sorry, multiplying to positive 9, subtracting negative 12. So I know both these signs are minus. That's for sure. So it's either going to be 9 and 1 or 3 and 3. Let's try 3 and 3. And when we multiply, we get negative 6 and negative 6. So this is 2p minus 3 squared. A binomial squared. Last one, this is another difference of squares, difference between perfect squares. So we already talked about how to factor that. A plus b, a minus b. On the next slide, we're going to do the exact same thing, except now we're going to use the zero product property and solve. On the last slide, there was nothing to solve. There's no equal sign, so we just factored. But now we solve. So let's try to factor this. We get x minus 4x plus 1, which means either x minus 4 equals 0 or x plus 1 equals 0. So x equals 4 or x equals negative 1 are our two answers. Number 2, well, first thing we need to do is get this in standard form by adding the 4 over. And now we are going to want to try to factor this. Let's see if we can come up with a factorization for this one. So 9x squared, we can maybe try 3x and 3x. And for 4, let's try minus 2 and minus 2 because this is negative here. And this is going to work out nicely. It's not minus 6x, which is minus 12x. So either 3x minus 2 equals 0 or 3x minus 2 equals 0. There's no point in solving it twice. So add 2, divide by 2/3, divide by 3, and we get 2/3. Number 3. Let's see if we can factor this one using our guess and check method. I know 5x squared is going to be 5x and x. So for 6, it's either going to be 1 and 6 or 2 and 3. Looks like it's going to be 2 and 3. Again, since this is positive and this is negative, these are both going to be minus. And let's take a guess. Let's take a wrong guess first here. Let's say this is 2 and this is 3. This would be negative 15. This would be negative 2. That would be negative 17. So that's not correct. Let's flip those. Negative 10, negative 3. That's negative 13, so that's correct. So either 5x minus 3 equals 0, or x minus 2 equals 0. So 5x equals 3, x equals 3/5, x equals 2. All right, this one, another one is not in standard form. So let's subtract 3x over and add 5 over. And now we can take out a GCF of 2. In fact, since it's an equal sign, we can just divide through by 2. Now if we factor this, it's going to be x minus 5 times x minus 5 equals 0. So x minus 5 must equal 0, so x must equal 5. All right, the last one here is a little word problem here using a quadratic equations model. A yearbook editor is designing a page layout. The outside dimensions of the page are 12 by 9. The white border around the rectangular printed matter on the page is twice as wide in size as it is on the top and bottom. So you can see here, I already did this here. This is twice as long as this, is what that says. So this would also be x. This would also be 2x. You can kind of go all the way around and do that, x and 2x, all the way around. So this rectangle in the middle, the dimensions of that rectangle are going to be 12 minus 2x minus 2x, so minus 4x. And then the right side and left side will be 9 minus x, or minus 2x. I know the area is 56, so I know 12 minus 4x times 9 minus 2x equals 56. All right, if we multiply this out, 9 times 12 is 108. Minus 24x minus 36x plus 8x squared equals 56. Get in descending order, so 8x squared minus 60x plus 52. Hope I'm doing my math right there. And now we got to try to factor this, but we can divide through by 4 and get 2x squared minus 15x plus 13 equals 0. Now if we try to factor this, it's going to be 2x and x, and it's got to be 13 and 1, and these got to both be negative. So either x is going to be 13 over 2, or x is going to be 1. Let's take a look. If x is 13 over 2, which is 6.5, if x was 6.5, could this be 6.5 and this be 6.5? It could not, because that would be 13, but this whole side is only 9. So this answer of 13 over 2 is out. Could x be 1? Sure it could. 1, 1, and 2, 2. It could definitely work. So x must be 1. So the question says, what are the dimensions of the printed area? Well, 12 minus 4x would be 12 minus 4, which is 8. 9 minus 2x would be 9 minus 2, which is 7. So dimensions are 8 inches by 7 inches. And double checking that, that does give us 56 square inches of matter. That'll do it for our video on basic factoring of trinomials and some perfect difference of squares, binomials. Thanks again for tuning into the video, and I hope to see you again soon.